Hey guys, welcome back to Tutorimane. I'm going to be continuing the last class videos right now. So the topic for today is like isomorphous and polymorphous solids. Let's see what isomorphous solids are. If two or more solids having the same crystalline form or structure, they are called as isomorphous to each other. Suppose if there is two solids substances which exist in the crystalline formation and have crystalline properties, or if their structure is also same to crystalline form, then they are called as isomorphous to each other. Make a note of the examples, you might need it. Examples are Epsom salt, that is MgSO4.7H2O is nothing called as Epsom salt. And next one is ferrous sulfate heptahydrate. You don't need to know the name, just remember the formulas or the equations, which is very important. These are all isomorphous. Na2S and Ag2S show isomorphism to each other. That's why I've given two examples. These are isomorphs, they show isomorphism, so please do make a note. And the next one is polymorphous solids. Polymorphous solids are like when the substance have two or more crystalline forms and their chemical position but different arrangement of constituent particles is polymorphism. You just have to, I can't break down this anymore because it's a definition, so just try and understand what polymorphous solids are. So substances existing in more than two crystalline forms and having similar chemical composition, not same, similar, but their arrangement of particles are completely different. So that is what is called polymorphism. There's an example, zinc sulfide in the form of zinc blende and woodsite. This is the only example which I can give you right now. In case of elements, polymorphism is also called as allotropy, and all crystalline allotropes are polymorphs to each other. So in case of elements, polymorphism is also called as allotropy. All allotropy elements are polymorphism in nature or to each other. So make a note of it. Moving on, we have a crystal lattice. This topic is really important because this forms the basics for your problems, equations, and many more to come. So try and understand it very clearly and do make a note of it. We'll see what a crystal lattice is. It is also known as a space lattice. Many other names are there, but these two are more important. Crystal lattice and space lattice, both are same. Okay, what is a crystal lattice? It's like a three-dimensional regular arrangement of a lattice point in space or in a crystal is called crystal lattice. Now we know crystalline solids have long range orders. That means they are repetitive even over a long period. So what happens is they have the same properties and they are in the same form. If you see, it's like it's in the three-dimensional and everything is repeating in the same order everywhere. So this is nothing but this is the same thing. It's a three-dimensional regular arrangement of lattice point. I'll come to what lattice point is. This is arrangement is in space or in a crystal. That is called crystal lattice. There's a diagram which is crystal lattice. So take a look at it. All the cubes which you can see are repetitive from behind, top, below in three dimension. In y-axis, x-axis and z-axis, it's the same. So that is why it is repetitive. So this is a crystal lattice. Okay, so now we'll see what characteristics of a crystal lattice are. Like I was telling you what a lattice point is, each gray point which you can see, I will show it to you. Try and observe it carefully. If you can see, 1 second, I'll show it to you. Yeah, so each and gray point which you can see, if you can see, I'm marking them. These are all lattice points. So each point in that cube, every single point is called a lattice point. The point refers to as particles. These particles, constituent particles, can be ion or an atom or a molecule. So that's what I'm telling you, it's an atom, ion or molecule. So the points are joined by straight lines. If you can see, it's straight. This is because to show the geometry of the lattice, that is on how it is actually looking in. So they draw straight lines, so they have to see the geometry of the lattice. Now you can also see that there is a box which is gray in color. If you can see, it's highlighted. That is nothing but unit cell. I am going to be talking about it in the next slide. It's nothing but unit cell. Make sure you take a look at it, because I don't have the same picture repeating. So the focused or the highlighted part of the crystal lattice is nothing but a unit cell. So we know that crystal lattice is like a three-dimensional arrangement, and lattice points are there and the lines are drawn so that they can maintain the geometry of the lattice. There are 14 possible three-dimensional lattices. There are 14. These are nothing called as Bravais lattices. I am going to explain more about it, but just remember how many types? 14. It's important, and it's called Bravais lattices. Moving on, unit cell. I showed you, right, the diagram. So let's take the definition. The smallest repeating unit in the space lattice, repeated over different directions, produce complete crystal lattice. So I think by now you have observed that that cube is repeated a number of times to form the crystal lattice. Long range order, if you remember, that's what it means. So unit cell is the smallest repeating unit in space lattice, which is repeated in different direction. It may be x, y, or z axis to produce a complete crystal lattice. Next, parameters of the unit cell. There are two parameters according to me. One is the edge length and one is the interaxial angle. We'll see what the edge length is. It's the dimensions along three edges A, B, C, which may or may not be perpendicular. So can you see that it's a z-axis here, and this is the x-axis. I know it's not clear, I'm sorry for the picture. And this is the y-axis. If you can see, it's the cube is sitting on the origin, and the lines are it's overlapping with the axes. So these lines are nothing but edge length. You can see, hopefully I'm marking them. So that is A, B, and C. Those are known as edge length. How long is the cube, or how many centimeters or inches, or how is the cube sitting on the axis. Next, these may be or may not be perpendicular. You don't know the angle of them. Now we're going to come to the angles. It's called as interaxial angle. Those are nothing but alpha. This is the angle between B and C. You have beta. This is the angle between A and C, and then you have gamma. This is the angle between A and B. I hope it's a little clear for you now what angles or what side. So to make it more understanding, I'm going to make it clear for you. So OA, is equal to OA is equals to A, small a, origin, and B is equal to B, O, C is equal to C. Now I think it's more clear. So moving on. Types of unit cells. There are different types, so you need to be knowing about them. There are two prominent types. There are two prominent types. The first one is the primitive unit cells. Now we know, you've seen a unit cell and you know how many points are there in a cube. There are 8 points. So in those 8 points there are particles. Those particles are nothing but ions, constituents, particles, ions, molecule, or an atom. So primitive unit cell, these constituent particles are present only at the corners. 8 points are on the corners. For example, can you count them for me? So this is 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 and it's all in the corners. So that's why it's called primitive unit cell. Non-primitive or centered unit cell. So there can be many points, okay, in this. It can be one or more point. And again, in non-primitive, there are again distinguished into 3 more types, which is called a body-centered unit cell. In this, there are 8 corners again, and there is one in the middle. It will be somewhere in the middle like this. Like this. This is nothing but body-centered. And then you have face-centered, okay. Face-centered, it's like 8 points again, and then you'll have 6 in the faces. It's not your face, it's the face of the cube. So we know that for a cube there is 6 faces. 1, 2, 3 behind, 4 down, 5 in the side, and 6 is the front part. Can you actually make out where I've written what? Because that's the 6 faces of the cube. So what is going on, meaning I'm going to use a new color. Okay, now I'm going to point out all this that you already know. There are 8 points, 8 particles. 1, 2, 3, 4, 5, 6, 7, 8. The 6 I'm showing you where it is. 1 is here, 2 top, 3 side, 5 again side, bottom, and 1 in the face. Can you make that show that? Can you imagine in 3-dimensional, these are 6 sides and there are 8 particles and 6. This is what it means, face centered. Then there's another one, it's end centered. 8 points again in the corners, that is fixed, and 1 in the center of the down or up face of the crystal. So this is the down part, this is the up part. Up, down. So there will be one more particle which can be either here or here. If that is the case, then it is called end-centered. I'm going to have diagrams to show you, so let me show it to you. So this is the body-centered, face-centered, end-centered. Okay, you want me to mark it again? So see, this is in the middle of the body. Can you see? Middle. In here, if you see, this is I'm going to mark in yellow the corners. 1, 2, 3, 4, 5, 6, 7 here, and this is the 8th one. Okay, so the one I'm going to mark in blue is the face centered. 1, 2, 3, 4, 5, 6. So can you make the difference now where I've marked? So that is the face centered. In here, this end centered can either be at the bottom or at the top. Like, it's very simple. Now we know what the crystal systems are. So we know there are 2 fundamentals we actually see in a unit cell: edge length and interaxial angle. Based on those definitions, or taking the angles or the length, everything into consideration, crystal systems consist of 7 variations, 7 types. After taking the axial length and interaxial angles into consideration, there are 7 types of crystal systems. First one is the cubic, the basic cubic. You can see. The next is tetragonal. It's I'm going to explain each and everything in the next part. Orthorhombic, monoclinic, hexagonal, that's a hexagonal, rhombohedral, and triclinic. Guys, you need to make sure to make a note of it, because they might ask you for a short question, or they might confuse you in your CET or in any exams you take. This might be an important question. They can make many number of MCQs here. So the triclinic looks like that. So let's say I'm going to continue about what next is. Explain each of them, how it is, how it behaves, how the axial lengths are, how the angle is. And I'm going to talk about Bravais lattices more, because there are 14 types we have to discuss about it. So thank you for watching Tutorimane. Please come back and please do subscribe, like and share for more videos. Thank you.